we were talking about measures of central tendency, which is how to find the middle of data. Now we're looking at measures of dispersion, which is basically how spread out is our data. So we're going to start with an example. To order food at a McDonald's restaurant, one must choose from multiple lines. While at Wendy's, one enters a single line. So here's our data representing the wait time for 30 customers at each restaurant. And for each of these, I want to find the mean, and then I want to look at the histograms to compare the wait times at each. I want to do the mean on the calculator. Now yesterday we did that and showed you how to put that all in. You can do these one at a time, but you can also do it all at once if you put one of them in L1 and one in L2. Okay, so we're going to take a second for you guys to all type this in. Remember, first step is go to Stat, Edit. You should probably have something entered here. To get it out, you go up onto the title. So I go up to L1, hit Clear, and then Enter. So what I want you to do is put all of your wait times at Wendy's in L1 and your McDonald's times in L2. Calculator or Chromebook here. Especially on custom quizzes, make sure you're taking the time to go back and double check all of your numbers and make sure you didn't miss any or type one in wrong when you do this. Where did we go to get the mean yesterday? Stat, Calculate. So go back to Stat, over to Calculate. Now yesterday we did one variable statistics because we only entered one set. So today we're going to do two variable because I just entered two sets. Okay, as long as you use list 1 and list 2, you don't have to change anything, just hit enter through all of that.
Mr. Question.
Yep.
So I skipped a whole row.
It doesn't matter what order you type them in, just
Okay.
put it at the bottom.
Thank you.
If we have different numbers, that means you probably mistyped one, which can happen pretty easily here. Okay, so then it tells me it uses X for one of them and Y for one of them. The mean is X bar and Y bar. So the mean of the first one, which was Wendy's, is 1.3907. Stat, calculate. Calculate. Two variables statistics. Just hit enter through all of that. Alright.
Would it matter if we put them in a different one?
No. You can switch orders anytime. Okay, so the mean wait time, Wendy's is 1.3907. McDonald's, if you look down, that's the, not what I meant to type pull up there. That's the Y bar, so that was 1.3893. And so we compare the means of the two. Okay. So what do you notice looking at those two means? Yeah, Wendy's is a little bit bigger, but is there a significant difference? .39 versus 1.389. They're really very close to one another. So the question is, does that mean it's the same at either one? We can do histograms on our calculator we've looked at, but just for the sake of time, I just went ahead and made them for you so we didn't have to go in and do each one. So this is the graph of Wendy's, and this is your graph at McDonald's. Look at these. Wendy's kind of has its peak here and its skewed to the right. McDonald's peaks right there. They're both skewed right. Do you notice anything about those? You know, Wendy's, we start at 0 and end at 4. The McDonald's one starts at 0 and ends at 5. So McDonald's is a little more spread out, isn't it? So even though the means were the same, it looks like Wendy's might be a little more consistent in the amount of time. You know, most everybody is grouped kind of right here, whereas McDonald's, if you don't get waited on immediately, you could pretty much be anywhere between 0.5 and 5. So the mean doesn't give you the full picture. Looking at the mean, these are the same. If I'm looking at these graphs, I'm saying it's actually probably a little bit faster at Wendy's because they're more consistent and they serve everybody about the same time. So a couple things that we look at here. First one is range. That just tells you the difference between your largest data and smallest data values. So it's just the highest minus the lowest. That's the first thing that we could look at to give us a spread, to help tell us how spread out those things were. So yesterday I used the example, we had 7 employees at a web company. If I went back to that data and said find the range, what's the highest point we saw there?
43.
Minus the lowest.
5.
And we get a range of 38. Okay, so that's telling us they're spread out by about 38 minutes. Okay. The second thing that we look at to tell us the spread is standard deviation. And this is a little more complicated. So if you look at this, these formulas just look downright scary, really. It's got a bunch of letters, Greek letters, all kinds of stuff. The notation for sigma, or for standard deviation, if you're talking about the entire population, is this Greek letter called sigma. And so there's a couple different ways it can be calculated. You can either take essentially each point minus the mean, square them, add them all up, divide by our number of points, and square root that mess. Or we can square each individual value, we can square the sum of all the values, or dividing by the total number, square root. It's a big mess, no matter what. This is not necessarily a formula that I'm going to expect you to memorize. Okay, I would give it to you. Probably, what am I going to give you? I'm going to give you a formula sheet. I'll probably go ahead and give it to you today. And I will give you a copy of this formula sheet on all of your tests and quizzes from now on. So I will hand that out in a little bit. And this, I will give you my copy, not one of these. So if you write on it, you won't have those notes on your tests and quizzes, but I will give you the formula. You just have to be able to use it. So if I asked you to find standard deviation for this, we're going to do standard deviation by hand, and then I'm also going to show you how to do it on the calculator. When it comes time for a test or quiz, I might ask you to do one of the problems by hand, and then any others we would just do on the calculator. So you'd have to do it once to show me that you could, but it'd probably be a small set of data because it's time consuming. And then after that, I would just have you plug it in. So I want to use, I'm going to use this first formula. All right, and I want to find standard deviation for that set of data. Please don't clear out this data in your L1 and L2 right now. We're going to go back to that. We're just going to use the calculator part. So let's make a table. And I'm going to put x sub I. That's going to be just our individual values that we saw. So we're going to have 7 of those, the 23, 36, 23. You have to list it every time it shows up. Okay, if I'm using the first formula, for each of those values, if you look at your formula, it says you have to subtract the mean. So I'm going to do that value minus the mean and get an answer. And then we have to square that number and get an answer. Okay. From yesterday, didn't we find the mean of those yesterday? Does anybody have that written down in your notes? It was like 24.5. 857. Okay. I will say that on this, if you round too much on your mean, it will throw your answer off quite a bit, so it's very important to show me your work. 3 to 4 decimal places is usually good. So for each of these, I'm going to do my number, so 23, minus my mean, 24.857. And while I have that entered, I'm just going to go ahead and do the second thing. I just square it. You can keep all the decimal places. We could round it to 4. Again, rounding is going to change things a little bit, but that's why it's really important just to show me your work. So let's just round it to 4 decimals for now. Okay, next one. I do 36 minus the 24.857. And then we square that number. This is 23. I've already done that, so I'm just going to copy it down. $18 minus 24.857. And then square that. Does everybody know where I'm getting my numbers? 5 minus 24.857. Squared. So not really difficult, but absolutely time consuming. It just takes a while. All right, so I've gotten this table filled out. Our formula then, we're using that first one that said our standard deviation was the square root of, this symbol means the sum. So we're going to add up all of those, divide by n. So I need to add up my final column here. So adding these numbers. You guys can do it too and double check me.
So,
Yes.
what did you say was the sum, mid, the sum?
This thing right here. Okay, when I add all of those up, you get 902.8568. Is that what you guys got? Just a fun little tidbit. if you add up your x minus your mean, you should get 0. Because the mean is the middle, so it should always balance out. Now we rounded these, so it may not be perfect. But if you were on a test and you wanted to make sure you hadn't completely messed up one of those numbers, add that middle column and it should be 0, just for a quick check. If we add ours up, what does it give us? I get 0.001 when I add mine up, which is pretty close to 0 with rounding. Okay, so now our standard deviation, our sigma, is the square root of this sum divided by capital N. What is N going to be? N is just the number of points. How many points do we have? 7. So type that in your calculator. And I get a standard deviation of 11.3569 minutes. So that's essentially the spread of our data. The larger that number, the more spread out it is. A small standard deviation means all the values are fairly close to one another. A large standard deviation tells you they're very spread out. Okay. We can do standard deviation for a population or a sample. The difference is the letter, essentially. So we use sigma for the population. When we're talking about a sample, we use a lowercase s to represent the standard deviation. So sigma for a population, s for a sample. Again, I'm just going to go ahead and hand this to you. Your formula sheets that you will have all of this on here. And you get to use the formula sheet on everything from here on out. So it tells you under chapter 3, how to find the mean. It even tells you population mean is mu, sample mean is x bar. Same thing, standard deviation, it tells you sigma for population, sample is s. So you've got all this right here on your formula sheet. Sometimes we talk about degrees of freedom. Degrees of freedom, if I ask for it, that's n minus 1. It's the number of points minus 1. So the last one, I had 7 data points, so it would be 6 degrees of freedom. So it's 1 less than your number. Okay, so what I want to do is just calculate one more standard deviation by hand, and then we'll look at doing it on the calculator. So this one, I just took a sample of 3 employees from our company of 7. So I want the sample standard deviation. I want my x. Now the setup is the same. You make your table. You have your x's, which here we had 5, 26, and 36. We have to do each of those. If you're looking at your formula sheet, it tells you, I'm just going to use that first one there. So x minus x bar, so we have to subtract the mean. And then we have the square. Now, x bar is the mean of the sample. So what do I need to do first here? Find the mean for these 3. So we add those 3 up. divide by 3. Oops, and I get a mean of 22.3333. So now I take my point, so 5, minus my mean, so minus 22.3333. Square that. And I'm just rounding to 4 decimals. So next one, my value is 26 minus the mean, 22.3333. Square that. And then 36. If you wanted to double check yourself, what should this middle column add up to? 0. Will it be exact? Probably not, but it should be very close. Okay, what we need to do for our standard deviation is add up the last column. So then this is a sample standard deviation, so we do S. The formula is on your sheet. Says you add up the sum of your x minus x bars squared. So we added all those up, we got this. And this time, for S, we divide by n minus 1. So we had 3 points. What do I divide by? 2. So we get a standard deviation of 15.8219. If you want to put a label on it, this is minutes. We were talking about commute times. So which one has a higher standard deviation? The entire population or this sample of 3? The sample. So what does that mean about these 3 points? The bigger the standard deviation, the more spread out they are, the less consistent they are. Okay. Let's compare our standard deviations from that first example, the wait time at McDonald's and Wendy's. Now, we have all that entered in our calculator already, so we don't have to redo it. If you go back to your stat, calculate 2 variable statistics again. So the same place we went to get our mean. This has your standard deviation right here for you. So definitely a lot faster if we can look at it this way. So the standard deviation for the first group, what do you guys have? It's that S sub x on there.
0.7384.
Oh, I flipped the order of my charts on this slide, didn't I? Sorry about that. I did them backwards. On the last one, I did Wendy's on the left. This one, I switched it to the right. Sorry about that. So, for Wendy's, that was our X. And what did you tell me? 0.738. This is minutes. We're just talking about that wait time. Okay, my Y was my McDonald's. So you're going to have to go down until you find that S sub Y. 1.2649. Okay, does this match what we saw when we looked at the bar graphs? We looked at those histograms and we said they have about the same mean, but Wendy's was more consistent. And if you look, they have a smaller standard deviation. So that tells us the same thing. They're more consistent in their wait times. I'm going to do one last thing and then I'm stopping for today. Okay? So the last thing I want to mention is variance. Variance is the same for population and sample, you just square the standard deviation. So variance is just standard deviation squared, which might be sigma squared if we're talking about the entire population, S squared if we're talking about the sample. So if I went back to, I asked you to compare the population and sample variance for the times. Go back to your examples 3 and 4. I'm just trying to reuse some of the data from before so we're not recalculating everything. So on this one, example 3, our standard deviation was here. If I want variance, that's sigma squared. So you just take that number and square it. That's variance. Again, the nice thing is, guys, I'm giving you this formula sheet, so if you forget what something means, if you can't remember what variance means, you look at the formula sheet and it tells you. Population variance is sigma squared. Sample variance is S squared. So on example 4, that one we just had a sample. We were only looking at 3 points. So we found the sample standard deviation. So if I want the variance, that's just S squared. And we get 250.3325. So variance is just standard deviation squared. Same thing for population or sample. Questions there? On Monday, you guys will be online. You're not going to see in the classroom stream a video posted. Where do you go to find it? Class documents, and then just pull up the YouTube page. And I'm just going to talk about the last bit. It's very short. Empirical rule, which is actually word for word on your formula sheet, so you don't even have to memorize that. Chebyshev's theorem, that one is not on the formula sheet. You might want to add it. Chebyshev. And then talking about weighted averages. So I will probably only teach for like 15-20 minutes on Monday. The rest of the time will be to work on homework. So the assignment for this, I think I printed it on your notes handout, didn't I? You might need to modify it. I think I printed an assignment on your notes handout, but I took out a problem afterwards. So on your handout it says 12 through 18 even. I actually took out problem 16. So this is the assignment, the one on the board, no problem 16. Several of these, like you're ready to get a good start on this. You know how to do a lot of them. The beginning ones are asking you to do like range, variance, and standard deviation. What I would like for you to do, if you could do one problem by hand just to make sure you know how. So 1 or 2 problems by hand, minimum of 1, and then you can use the calculator on the rest of them. I don't expect you to work it all out by hand. Problem 12 or 14 would probably be good ones to do by hand. 18 and 22 I'd probably do on my calculator. So at least try 1 by hand. You can do more than 1 if you want, but on a test or quiz, I will say have 1 problem where I ask you to do it by hand.
Sharpie shows the 1 minus 1 over k squared times 100%.
Mm-hmm.
Okay, thank you.
You're welcome.